All right, so we're staying in front of a VF3 Haas, a 3-axis mill. And what I want to show you is how to set a work offset on this machine. And the first thing we do when we first come in the morning is home out the machine. So the spindle is at its most top position, so that will be Z0 home position. And also the table is far left and all the way to the front. That is the home position. And so when you look at the screen and you set it to the position page, then you can see that the machine position is currently sitting at X0, Y0, and Z0. So what we're going to do is I'm going to show you how to find the work offset for this part. And we're going to find the center of that part and store it in G54 work offset. And we're going to be using a edge finder that has a 200 thousandths pilot diameter. Here it is loaded. You can see the edge finder has a 3/8 shank and a 200 thousandths diameter pilot. So the center line of the spindle is 100 thousandths away from the edge, from the pilot diameter. I'll go into that a little bit more. All right, so the first thing we do is go into MDI, and I have programmed it for 900 RPM. And so now when I hit cycle start, basically the memory of the machine knows that if I want to manually turn on the spindle clockwise in manual mode, so I'm going to turn it to handle, click clockwise. Now the spindle turns at 900 RPM, and that's a good RPM for that edge finder. Now you can see it's wiggling a little bit. We can straighten that out. You can kind of rub your finger up against it and notice how it sits still. So we're going to move that up against the part, and when it breaks just like what you see right here, that means we have found the edge of the part with an accuracy of about 1/1000th. So let's get started on how we do that. So we go into handle mode and we pick 10 thousandths per click, and we're going to move the handle in X, and we're going to turn the hand wheel and move the spindle to get close to that part. So we're going to move in a X minus direction. All right, so the table is moving right, but always make sure you look at the spindle in relation to your part. The spindle in relation to your part is moving in a negative direction. Okay, so that is the way you would turn the hand wheel. All right, so we're going to feed close with our spindle, and we're going to get the tip of that smaller 200 thousandths pilot diameter just below the top of that part. Okay, probably a couple 100 thousandths. We want to make sure we don't hit the 3/8 diameter portion of that edge finder. All right, so then we're going to switch axis and start approaching that part. So we're moving in the X plus direction right now, and we're feeding in 1/1000ths per click increments. And the closer we get to that edge, you can see it's starting to line up and smooth out. And as soon as it breaks, and we're moving 1/1000ths at a time, and you got to look real close to see it, but there it is, there it broke. So that was one click, and you can see it is not running even with the 3/8 top portion. So that means we are exactly 100 thousandths away from that edge, okay, the center line of that spindle, because that pin is 200 thousandths. So then we go to the position page, and we're going to find the position operator page, and we want to at that location zero out the X axis. So we click on X, and we select origin. So then it should read 0. So then we're going to turn the spindle off. We're going to raise it up, clear the part, and we're going to move it over to the other side, and we're going to do the same thing. We're going to turn the spindle back on, and we're going to approach the part in the X minus direction until it does the same thing. Alright, so we're going to turn the spindle back on and start feeding 1/1000ths at a time. You can approach it fairly quick. If you accidentally bump it, it's not a big deal. You just back off a little bit. But once you get close, you just want to move 1/1000th at a time until it smooths out like it's doing right now. And then again, it should break. There it is. There's that break. So now, again, that center line of the spindle is 100,000ths away. But what you're interested in right now is the overall distance that you traveled from the left side to the right side. And in this case, that is 2 inches 268. So we're going to have to divide that in half. So that will be 1 inch 134. So we're going to raise the spindle up, and we're going to physically move to that X 1 inch 136 location. So let's do that. We're going to turn it to the handle mode, 1/1000ths increments. Select the X-axis. We've already raised it up, so now we're going to look for that physical position, 1 inch 134. So that is the exact center of that block. So now we're going to have to store that location. So we go back to the offset page, and we're going to find the G54 work offset, and we're going to highlight the X. And then we're going to store that position where we're currently at, and we do that by selecting part 0 set. So when you're at that position, you click on it, watch the numbers change. So there it is. So now the machine knows the distance from home position to the center of that block, and that's how a work coordinate works. So you do the exact same thing on the y-axis. You pick the far edge, front edge, divide it in 2, and store that position, and now the machine knows exactly where the center line of that part is.
Alright, so now that we're done with G54, we have all these other stations that we're going to assign work offsets for. Now we have 16 different stations. So let's take a look at the available work offsets here. So right now we have set G54, but notice not only do we have G54 with 55, 56, 57, 58 and 59, and those are the common ones in other machines, but the Haas machines has the G110, 11 and so on, and if you page down it goes all the way down to 129. So that's very handy when you have a setup like this where you have 16 parts. So that is how work offsets are used and set. Next we're going to talk about how to touch off tools and how to find the Z0 on top of the parts.